Alright, here we go, Algebra 1. This is Chapter 6. We're going to start off with the 6-1A notes. Now, a lot of stuff in this chapter is dealing with formulas that you will see on your formula sheet for the Keystone Algebra 1 exam. So I will identify them and show them to you while we go through this. Usually on all the tests that we give you, we will give you a formula sheet for your tests and quizzes because you're given them on the Keystones, and that's our goal, is to prepare you for the Keystones. So I'll point out the formulas to you, but they will be on your Keystone formula sheet. So here we go. We want to label these points using the coordinate pair. So A, if I look at point A, okay, here's point A. So right here, if I'm going from the center, count them off. It's 1, 2, 3, 4, 5, 6 to the right. So that means my x coordinate is 6. And then I go up 1, 2, so my y coordinate is 2. Alright, let's go. Next one, B. To get to B from the center, okay, I'm going to go 1, 2, 3, 4 to the left, which means B will be labeled as a -4 for the x coordinate. Count them up, 1, 2, 3, 4, 5 up, so +5 for the y coordinate. Pause the video, try C and D on your own, and see what you get for them. Alright, C, right here, C. From the origin, we go to the left 1 unit, so that's a -1. So hopefully you got a -1. And then down 1, 2, 3, so it's a -3. And for point D is right on the y-axis, so we're not going left or right at all, so the x-coordinate is 0, not moving left or right. But we're going down 1, 2, 3, 4, 5, 6, and 7. So that is a -7. Okay, and as I had mentioned before, any point that lies on the y-axis has a special name that is called the y-intercept. We're going to talk about that a lot throughout this chapter, so get used to that terminology. A point that crosses the y-axis is called a y-intercept. Alright, so when we are measuring the steepness of a line, we have a couple of terms that we will use for this. The first one we're going to talk about is slope. So slope, fill that in. Slope is the measure of the steepness of a line. Here's another term, rate of change is another thing that we will use to represent slope. And this is your slope formula, okay? Typically on your formula sheet it will be written like this. The variable m is used to represent slope, y2 minus y1. What this means is that it's the final y point minus the initial y point, and then x2 minus x1, which again, final x coordinate minus initial x coordinate. When we look at a graph, we look at this as rise over run, so we could just count off points going up however many points and then over however many points. We want to make sure we leave this as a fraction, so this must remain a fraction. And we want to leave it as an improper, might run out of space, improper fraction. Okay, so no mixed numbers. Okay, I'm just writing down some random, it's not random, some added information here. No mixed numbers. So you do not want to, if you get a slope of like 5 over 2, we want to leave it as 5 over 2. We do not want to write this as 2 1/2, okay? Because we want this to be in the form of rise over run. So now it is very, very important that we leave things as improper fractions, no mixed numbers. Alright, so let's go here. We'll talk about the slope of 0 and an undefined slope eventually. These are the two that students tend to get mixed up the most. But here's some, if we look at if a line starts at the bottom left and goes to the upper right, that is a positive slope. It's going up as we look at it from left to right. Just like when you're reading, we look at these from left to right, it is going up, so that is a positive slope. As we look at it from left to right, if it's going down, that is a negative slope. Something is decreasing, it's going down, okay? No slope means it stays perfectly constant, perfectly flat, and an undefined slope means that it is a perfectly vertical line. Alright, so let's look at an example here. What is the slope of the line graph below? We're going to find it using rise over run, and then we will use the formula. Okay, if you are given the graph, rise over run is always the easiest. Okay, now what we need to do is we need to find 2 points where this line crosses through exactly. So I will show you all of the options. Here's one, here's an option, there's an option, right there, and all of these points you can see hit the graph exactly at those points. We only need 2 of them, so take your pick, any 2, it doesn't matter. So if I go from, I'm going to change the color up here, if I want to go from, let's do this point to this point. All right, if we're counting rise over run, we're going to count and see how many units do we have to go up or down, and then over. Okay, so if I start here, I'm going to call this point A and this point B. If I start at point A, how many units do I have to go down to get to B? And I'm going down 2, so that's -2. So that's my rise. And then the run, how many units do I have to go over? And that's just 1 unit. So that'll be rise over run, -2 over 1. Now let's say, so let me, first of all, we always want to simplify. This is just -2. Now, let's say, for example, I wanted to start at B and go up to A. Is that allowed? Well, yeah, absolutely. So we count this, we would go up 1, 2. So that would be a +2 over. And then we would go to the left. From here, we would go to the left 1. So that would be -1. But guess what? These two are the exact same point, or the exact same slope. And we don't have to use these 2 points. We could have chose any other 2 points on this graph. Like I could have picked, let's say, this point right here and this point. If I count these, I would go down 1, 2, 3, 4, 5, 6. So it would be down 6. And then over, if I'm starting here, over 1, 2, 3. So right 3, guess what? -6 over 3 is? -2. Okay, so it doesn't matter. They all lie on the same line, so they should all give us the same slope. Now, if I want to do this using the other form, so pause the video and write this down if you don't have it written down yet, because I'm going to erase it here in a second. Okay, the other way, using this formula, okay, if I'm going to use the formula y2 minus y1 over x2 minus x1, I need to label 2 points. So I'm going to just pick any 2 points here. I'm going to take this point right here. We'll call this A. So A has coordinates -2, 1. And then I'm going to take this point right here. So that's B. I'll label that B. B has coordinates, it's over 1 and then down 5. So over 1 to the right would be a +1. Down 5 would be a -5. So this is point 1, and this is point 2. So this is like your x1, y1, and this one over here, I'm just going to actually let me take this and slide this down. This would be your x2, y2. All right, so let's plug them into the formula. Now, one thing I would highly suggest you do, I'm going to put a little star here because this is what I would very strongly suggest that you do. Replace all of your variables with parentheses. So what this should look like before we start plugging anything in is this. And the reason why I tell you to do this is because you will have double negatives, and that is always the biggest problem that I see students have when they are using this formula. So put the parentheses there and then we'll fill in the numbers. So y2 is -5. So I plug in -5 for y2. Minus y1 is 1. x2 is 1. Okay, that came from this right here, the green underline thing. And x1 is -2. So we'll fill that in, -2. Okay, once we have them filled in, we can go ahead and add or subtract them and then simplify if necessary. So -5 minus 1, plug it in your calculator, that gives you a -6. And down here, again, we have a double negative, so that changes to plus. 1 plus 2 is 3. Now, we already knew that our final answer should be -2 because we did it by counting them off, but there is one way, another way that you can do that. And this is the way that we do it if we're just given the points. Okay? All right, next. Again, what I said, another term for slope is rate of change. So that's what we're going to fill in with this blank. Rate of change allows you to see the relationship between two quantities that are changing. Okay, the relationship is the rate that the two quantities are changing, so there's your rate of change. Okay, your dependent variable is your y variable, and your independent variable is your x variable. We talked about that when we did input, output, domain, and range, x and y. They're all the same thing. Okay, so let's look at a couple of these examples. So here we have a graphical representation of two roofs. We have roof A and roof B. Which roof is steeper? Now, I think you could probably look at this and say this roof is steeper than this roof, but we want to show that. So how do we know? So let's count them off. We want to look at the slope. So roof A, if I'm going to start right here and go to here, the rise, 1, 2, 3, 4. So my rise is 4. Over run, so how far do we have to run? 1, 2, 3, 4, 5. So 4 over 5 is the slope of that roof. Roof B, I'm going to start here and end up here. What's the slope of this? So do the rise. 1, 2, 3. So I'm rising 3. Over run, how far do I have to run? 1, 2, 3, 4, 5, 6. So 3 over 6, which reduces to 1/2. Which of these is bigger? Because the bigger number will be the steeper roof. So 4/5 is bigger than 1/2. If you need to look at that as a decimal, this is 0.8 and this is 0.5. That helps to see that this number is bigger, but that is steeper. Next, Kayla grows plant from a seed. In 2 weeks, the plant is 5 centimeters tall. Okay, so that means we have the point 2, 5. Okay, after 2 weeks, this is weeks. How tall was it? So after 5 weeks, after 2 weeks, it was 5 centimeters tall. Then we have this other point. In 6 weeks, the plant is 17 centimeters tall. What is the average growth rate each week that this plant will have between weeks 2 and 6? So we're going to subtract these. Again, we do, okay, this is your x1, back up. This is your x1, y1. This is your x2, y2. So we use our slope formula, y2 minus y1 over x2 minus x1. And before I plug in any numbers, I'm replacing all of my variables with parentheses. Okay? So again, I would highly suggest you do that. It makes it so much easier. So final y2 is 17 minus the initial is 5. And then the final x value was 6 minus the initial x value was 2. So we'll go ahead and subtract these then. 17 minus 5 gives me 12. Divided by 6 minus 2 is 4. The average growth rate is 3 centimeters per week. Final answer is A. All right, next. When a baby is born, it's 18 inches long. So if I'm writing a point for that, again, the first number is going to be the time, your number of weeks. So right when it's born, it's 0 days old or 0 weeks old or 0 months old, and it was 18 inches. 27 inches long at 10 months. So 10 months, it was 27 inches long, and we want to know the average growth rate of the baby each month. So again, M is for slope. y2 minus y1 over x2 minus x1. Let's fill in our parentheses before we fill in numbers. So parenthesis minus parenthesis over parentheses minus parentheses. So let's fill in our numbers. The final height of the baby was 27 at 10 months minus the initial was 18, sorry. The final weeks that we're looking at, months was 10 months. And we started out at 0 months. So let's subtract these. 27 minus 18. 27 minus 18 gives me 9. Divided by 10 minus 0 is 10. So the baby grew 9/10 of an inch per month. or you could say 0.9 for this one, but again, we want to leave this as a fraction for future things. So 9/10 of an inch per month. Last one here. Yep, last one. I was just double checking. What is the rate change of the graph below? This is the descent of a skydiver. So right here at time 0 seconds, the skydiver jumped out of the airplane, and then they started descending. So after 60 seconds, they were at this point. So we want to know what is the average rate change that they had. Now, we want to make sure that when you're doing this, it's not just 1, 2, 3. Each of these marks represents a certain amount of height, and you need to recognize that that's 500 feet. So like this line right here would be 1,500 feet, and this line right here would be 2,500 feet. So just keep that in mind. All right, so again, let's just count this off. So if we're doing rise over run, we're going down 1, 2 units. But again, we don't want to just put -2, because how far was that? And we want to actually fill in the number that goes there. So since each of these represents 500, it went down 500 feet and then 1,000 feet. So down 1,000 feet divided by, let's look at the run. So we have 1, 2, 3, 4, 5, 6. But again, we don't want to divide by 6 because each of these represents 10 seconds. So it's 10, 20, 30, 40, 50, 60. Oops, sorry, I missed my mark there. So this is going to be to the right 60. Okay, so we have -100 over 6. Reduce that again. We can divide each of those by 2 and have -50 divided by 3. We want to know the average rate of change, I don't know, per second or whatever. So -50 over 3. If you wanted to leave that as a fraction, that would be your final answer. But if you divided them, you could do 50 divided by 3 and have 16. It's going to, he dropped -16 and 2/3, what was that, feet per second. There's a couple different ways that you could write this answer. Either of those would be acceptable. Okay, so again, we're starting off this chapter 6 talking about rate of change and slopes and stuff like that. So if there's any of these problems that you have questions on, please let us know. Otherwise, work on the homework problems, and if you have any issues or questions or anything, just let us know.